Lesson 1. Quadratic equations. Let's start with an example. Let's take a look at x squared minus 1 is equal to 0. It is quadratic because the highest power of x is 2. And there's a constant term, which is minus 1. So we can rearrange and take square roots to get the solution of this quadratic equation, which is 1 and minus 1. So do you know what this means graphically? The graph of x squared minus 1 is a parabola which intersects at 2 points. We see that the graph intersects the x-axis at 2 points, which is minus 1, 0 and 1, 0. The x-coordinates of the intersections are the solutions of the equation. In general, every quadratic equation can be plotted to give two intersections. Now we will see how to solve a quadratic equation in general. In the previous example, what we really did is first we made the equation into the form x squared is equal to something, then we took square roots to obtain a solution. We'll do the same to all quadratics. Let's take a look at a general quadratic equation. We want to make this part the square of something, and we will do this by completing the squares. And it is done by adding a constant term to it. Now, it is a square of something. And when we put it back, we get this kind of equation, which we can now rearrange to give the desired form. So the square is equal to something. Now we take square roots to obtain a nice form. Now finally we rearrange and put the constant term on the right hand side to get the quadratic formula. But there are exceptions for the quadratic formula. When b squared minus 4ac is less than 0, we get a negative number. How do we do that? Well, in fact, we do this by defining the complex numbers. We define I to be the square root of minus 1, so we can square root any negative number now. Hence, we can write this for the quadratic formula. Let's take a look at the graph. This is x squared minus 1. When the parabola moves up, the two solutions converge. And when it moves up again, they become complex numbers. What does a quadratic equation look like in complex plane? Well, let's take a look at this equation. So, expanding, we get this. So in fact, we can plot the real part of this equation. This is what the real part of that equation looks like in three-dimensional space. We can now have a look at its zeros, which is a hyperbola. But not all points work, because we can only have I and minus I, because other points will make the imaginary part not 0. A quadratic equation is simple, but it reveals many things about mathematics. We hope you find this video helpful. For more information, you can scan the QR code coming up.